Good morning, student. See, in this lecture, we will see Knoevenagel reaction. In this lecture, we will see Knoevenagel reaction. It is also called Knoevenagel condensation reaction. It is also called Knoevenagel condensation reaction. Let us see. First, we will write an example of this, general example of this. Okay, this is what the general example of Knoevenagel condensation reaction. Let us see what is the statement of this reaction. Okay, so we can say Knoevenagel reaction is a condensation reaction of a aldehyde or ketone. It is a condensation reaction of aldehyde or ketone. What is this? Either this will be an aldehyde or a ketone without alpha hydrogen atom. This is important. Okay, so it is a condensation reaction of aldehyde or a ketone having no alpha hydrogen atom. Okay, having no alpha hydrogen atom with active methylene compound. What is this? Active methylene compound. Active methylene compound, isn't it? So it is a condensation of aldehyde or a ketone having no alpha hydrogen atom with active methylene compound in presence of base, to give a condensation product. To give what? A condensation product. It's called Knoevenagel condensation or Knoevenagel reaction. Understood? So there will be a loss of this oxygen and these two hydrogen. That means there is loss of water molecules. There is what? Loss of water molecule. Removal of water molecule. That is what? This is what a condensation reaction. So what kind of aldehyde or ketone we can take? We can take a aldehyde or ketone which are not having alpha hydrogen atom. Okay, for example benzaldehyde, for example benzophenone, benzaldehyde, isn't it? Such kind of aldehyde or ketone we can take in Knoevenagel condensation reaction. Now, which kind of active methylene compound we can take? What is X and Y? X and Y are electron withdrawing group. X and Y are what? X and Y are electron withdrawing group. So which kind of electron withdrawing group? So it may be cyanide ion, it may be nitro group, it may be SO3H, it may be COH, it may be CO2R, that is ester, CO2ET, CO2Me. Okay, it may be COR, that is ketonic group. X and Y. Okay, what is mean by X and Y? It may be aldehyde. So such kind of any electron withdrawing group, that is X and Y, if such group is attached to CH2, isn't it? Then this will be what? Active methylene compound. then this will be what? Active methylene compound. When such active methylene compound, we will react with such kind of aldehyde or ketone which is not having alpha hydrogen atom, then there is formation of condensation product in presence of base. Now which kind of base we can use? Let us see. Which kind of base we can use? We can use pyridine. Okay, we can use alkoxide ion, that is OR minus, OET minus, tertiary butoxide ion, like that. We can use again pyridine. Such kind of bases we can use as a catalyst in this reaction, Knoevenagel reaction, isn't it? Now, have you understood which kind of aldehyde or ketone we can take here? We can take a aldehyde or ketone which is not having alpha hydrogen, isn't it? We will require only one aldehyde or only one ketone for this reaction and active methylene compound. That means we cannot take both aldehyde and ketone as a mixture of aldehyde and ketone. Okay, so we have to take either benzaldehyde or we have to take either benzophenone, like that. Which kind of base we can use? Pyridine, alkoxide ion, pyridine, such kind of bases we can use in this reaction. Now let us see one example. Let us see one example. Benzaldehyde. Okay, we will react benzaldehyde with what is this? Ethyl acetoacetate. Ethyl acetoacetate. Okay, so here is a ester group, ethyl ester, and here it is what? Ketonic group. So ketonic group is also electron withdrawing and ester is also what? Electron withdrawing. Okay, hence these two hydrogen are what? Acidic hydrogen, or this methylene compound is called, methylene group is called active methylene group. Okay, so there will be a condensation of this benzaldehyde molecule. What is it? Benzaldehyde. With ethyl acetoacetate in presence of base like pyridine, pyridine, or any alkoxide ion we can write. So there will be a formation of, such kind of product, condensation product. This condensation product will form in this reaction. So this is what the example of this is what the example of Knoevenagel condensation or Knoevenagel reaction, isn't it? So let us see mechanism of this reaction. Let us see mechanism of this reaction, that is reaction of benzaldehyde with ethyl acetoacetate. Okay, we will take mechanism of this and let us write it. So have you understood what is the background about Knoevenagel reaction? So what do you think, which will be a first step of this reaction? What do you think, which will be a first step of this reaction? So obviously first step of this reaction will be what? Formation or generation of carbanion. First step will be what? Generation of carbanion. Generation of carbanion. So from which compound we will get carbanion? Active methylene compound or aldehyde or ketone? Obviously we will get carbanion from this active methylene compound like ethyl acetoacetate. Okay, so write this. So this compound is on reaction with what? Base. This compound is on reaction with what? Base. See, I will write these two hydrogen, these two proton like this. Isn't it? Same compound I have written here. Okay, just I have written two hydrogen in this way. So this base will abstract this proton and there will be a formation of carbanion. This base will abstract any one of these proton, there will be a formation of carbanion. Now write the carbanion, structure of carbanion like this. Isn't it? This is what? Carbanion. Now this carbanion will get stabilized. This carbanion will get stabilized over this ketonic carbonyl also and over this ester carbonyl also. So we can write a resonating structure for this carbonyl. We can write a resonating structure for this carbonyl like this way. In this way we can write a resonating structure for this carbanion. Similarly, we can write a next resonating structure like this. Okay, we can write two resonating structures. This is what the driving force behind the formation of this carbanion. Now, next step is what? First is what we have seen, generation of carbanion or formation of carbanion. Now, second step is attack of carbanion on carbonyl carbon of here there is benzaldehyde, so I will write benzaldehyde. Okay, on carbonyl carbon of, you can write aldehyde or a ketone if you are talking about general reaction. Otherwise you can specify it like benzaldehyde. What is the second step? Attack of this carbanion. Attack of this carbanion on carbonyl carbon. Attack of carbanion on carbonyl carbon of benzaldehyde. Write it. Okay. Write the molecule of benzaldehyde. I will write benzaldehyde molecule in this fashion. Okay. And carbanion. So this is what your carbanion. Is that clear? Now this carbanion will attack on carbonyl carbon of benzaldehyde. This is what? Carbonyl carbon of benzaldehyde. And when this carbanion will attack on carbonyl carbon of benzaldehyde, there will be a shifting of pi bonding electron density between carbon oxygen double bond towards electronegative oxygen atom. Isn't it? That pi bonding electron density will get shifted over electronegative oxygen atom. And what you will get? You will get, see, there will be a formation of new carbon-carbon bond. There will be a formation of new carbon-carbon bond. This new carbon-carbon bond will form and you will have a structure COCH3 and CO2 ET, isn't it? So this new carbon-carbon bond will form in this step. Okay, now what is this? This is a what? Oxyanion. Oxyanion. There is one proton. that I forgot to write here, as only one proton is abstracted, hence we can show that proton. So this is what oxyanion we will get. Now this oxyanion, okay, in next step, see here what you will get when base will abstract this proton, there will be a formation of a conjugate acid. There is formation of a conjugate acid of base, isn't it? There is formation of conjugate acid of base. Now in next step, see, there will be a protonation. Third step, protonation of oxyanion. Protonation of oxyanion. This molecule will undergo protonation. Protonation of oxyanion and loss of water molecule, followed by loss of water molecule. Followed by loss of water molecule, loss of H2O, isn't it? Let us see. CO2ET, COCH3. So this molecule will take proton from this conjugate acid BH plus, isn't it? So that I will show here like this. BH plus, so it will take proton from this, and there will be again generation of free base in the reaction. So what you will get? You will get pH COH H CH COCH3 and CO2ET, isn't it? Now next step is what? Loss of water molecule. Next step is what? Loss of water molecule. See here, there is what? Loss of this H2OH and this OH. Okay, they will lost as a water molecule, and there will be a formation of PHCH double bond COCH3 CO2ET, CO2ET, isn't it? So this is what the condensation product of this reaction, Knoevenagel reaction. Okay, I hope we have understood this mechanism. Okay, once again I am repeating it, the mechanism of Knoevenagel reaction. Let us see. See, what is Knoevenagel reaction? Knoevenagel reaction is a reaction of aldehyde or a ketone. Aldehyde or a ketone which is not having alpha hydrogen atom with a active methylene compound. With a what? Active methylene compound like this, in presence of base. In presence of base like piperidine, pyridine, okay, alkoxide ion, isn't it? To form a condensation product. To form a what? A condensation product along with water as a byproduct. So this is what Knoevenagel condensation reaction. Now let us see mechanism. First step is what? Generation of carbanion. First step is what? Generation of carbanion. So which compound will give carbanion? Obviously active methylene compound, isn't it? So we have written active methylene compound. We have shown the protons which will get abstracted to form carbanion. This is what we have written. Okay, so this is what a active methylene compound. So it is on reaction with base, there will be a formation of such kind of carbanion. Now this carbanion, okay, why it is formed? What is the driving force behind the formation of that carbanion is what? This carbanion will get stabilized through resonance. This carbanion is what? will get stabilized through resonance. So this is what resonance stabilization of carbanion. There is delocalization of this carbanion carbon, that is electron density of carbanion carbon over carbonyl group of ketone and over carbonyl group of ester. Thus this carbanion is stabilized. Thus the carbanion is got stabilized. Now in next step, what is the second step? Attack of that carbanion. Attack of carbanion on carbonyl carbon of benzaldehyde. Okay, on carbonyl carbon of benzaldehyde. So write benzaldehyde molecule, write that carbanion and show attack of this carbanion on carbonyl carbon of benzaldehyde. And at the same time you have to shift pi bonding electron density in between carbon and oxygen towards electronegative oxygen. As pi bond is weaker, hence pi bonding electron density will get shifted over electronegative oxygen, not sigma bonding electron density. So what you will get? You will get such kind of intermediate. You will get what? Such kind of intermediate, and this intermediate is called oxyanion. This intermediate is called what? Oxyanion. And this intermediate will have new carbon-carbon bond. This is what the new carbon-carbon bond is formed in between benzaldehyde molecule and active methylene compound. Now in next step, protonation of oxyanion. Protonation of what? Oxyanion. This oxyanion will undergo protonation from conjugate acid of base, and there will be a formation of such kind of intermediate. Such kind of what? Intermediate. Now this protonated molecule or intermediate, it will undergo what? Loss of water molecule. As the reaction is going on, it is having some heating condition. Okay, so there will be immediately loss of water molecule. This hydrogen and this hydroxyl group will get lost as a water molecule, and there will be a formation of unsaturation in the product. That product is what? Your condensation product. That product is what? Your condensation product. This is what? Condensation product. Now let us see application of this application of this Knoevenagel condensation reaction. Let us see first application. I will write here only. Application. So reaction of benzaldehyde, isn't it? Benzaldehyde with ethyl acetoacetate. With what? Ethyl acetoacetate in presence of pyridine. In presence of pyridine, what does it give? It gives this compound, active methylene compound, condensation product. This condensation product we will get. Now this condensation product is on reaction with what? Aqueous NaOH. Is on reaction with what? Aqueous NaOH. So this ester group will get hydrolyzed. This ester group will get hydrolyzed, and there will be a formation of such kind of acid, beta keto acid. There is formation of beta keto acid. What is it? See, this is alpha carbon, this is beta carbon. So this is beta keto acid, and they are highly unstable. Beta keto carboxylic acid, they are highly unstable, and it will, on heating, there will be a loss of carbon dioxide. It is on heating, there will be a loss of carbon dioxide gas, and there is formation of, there will be a formation of such kind of molecule. This is called benzylidene acetone. This is called benzylidene acetone. So we can prepare benzylidene acetone through this approach, through Knoevenagel condensation reaction. This is what first application of this reaction. We can prepare benzylidene acetone through this Knoevenagel condensation reaction. So how to prepare this benzylidene acetone? Take benzaldehyde molecule, react it with ethyl acetoacetate in presence of base like pyridine, piperidine. We will get such kind of Knoevenagel condensation product. That is on reaction with what? Aqueous sodium hydroxide. There will be a hydrolysis of this ester molecule into carboxylic acid functionality, isn't it? And in last step, when we will heat this compound at around 200 to 50 degrees Celsius, there will be a loss of this carboxylic acid functionality, that is carbon dioxide gas from this carboxylic acid, and there is formation of benzylidene acetone as a product, isn't it? This is what the first application of this reaction. Now let us see second application of this reaction. Second application of this reaction. What is this? Diethyl malonate. Diethyl malonate. When we will react benzaldehyde with what? Diethyl malonate in presence of pyridine, there will be a formation of such kind of condensation product. There is formation of such kind of condensation product. This condensation product on reaction with what? Aqueous sodium hydroxide, there will be a what? There will be a hydrolysis of both the ester functionality into corresponding carboxylic acid. There will be a what? Hydrolysis of both the ester functionality into corresponding carboxylic acid. And in next step, this compound, okay, this is what? Beta dicarboxylic acid. This compound on heating, there will be a loss of one of the carbon dioxide molecule, from one carboxylic acid group, and there will be a formation of cinnamic acid. Okay, see, there will be a formation of cinnamic acid, pH, CH, double bond, CH, COOH. There is formation of what? Cinnamic acid. There is formation of what? Cinnamic acid as a product. See, this will get lost and this hydrogen will come here. So pH, CH, CH, COOH. Okay, cinnamic acid will form. So this is what? Second application of Knoevenagel condensation reaction. This is what? Second application of Knoevenagel condensation reaction. So I hope you have understood what is meant by Knoevenagel condensation reaction. Which compound can we take as a aldehyde? We can take as a ketone. Which compound we can take as a active methylene compound? Which bases we can use? And what product is formed in this reaction? Okay, also you have understood mechanism in detail, and also you have understood application of this reaction. So I think you have understood all the topic thoroughly. Thank you very much. Wish you happy learning. Thank you.